Understanding quadrilaterals. Quadrilateral means a four-sided figure. When the figure has four sides, we can say that figure is a quadrilateral. But before studying what quadrilaterals are, it is important that you know that there are different types of polygons. And these different types of polygons are, starting with the smallest polygon, that is a triangle. A triangle has got three sides. So when it has got three sides, that is tri, which means three, and angle, that means this figure has three angles. Now these three angles and three sides could be equal or it may not be equal. So if it is equal, we say they are equiangular, or that figure is called a regular polygon. If the sides and angles are different, then we say that that figure is irregular. So here this is a triangle which has got three sides. Similarly, four sides is called a quadrilateral. This has got four sides. We have a five-sided figure. The five-sided figure is called a pentagon. A six-sided figure is called hexagon. A seven-sided figure is called heptagon. Eight-sided figure is called octagon. A nine-sided figure is called a nonagon. And finally, a 10-sided figure is called decagon. Now there are names also for 11 sides and 12 sides, but that will be beyond the course at the moment. So we have to concentrate on these polygons: triangle with three sides, quadrilateral with four sides, pentagon with five sides, hexagon with six sides, a heptagon with seven sides, octagon with eight sides, nonagon with nine sides, and decagon with 10 sides. So these are all examples of polygons. So when we refer to polygons, it can have n number of sides, and these are from triangle to decagon should be known. So this number of sides is normally represented by the alphabet n. So n stands for the number of sides of a polygon. Now basically we can classify polygons as either concave or convex. Now how do we distinguish between concave and convex polygons? The simplest way to distinguish between a concave and convex polygon is by drawing a figure and then constructing the diagonals of the figure. So if you have a figure like this is a random quadrilateral, it's a four-sided figure, name it as ABCD, and if we are going to draw the diagonals of this, that means join D to B and A to C, we find that both the diagonals are lying within the figure. So such type of figures where both or more than two diagonals are lying completely inside the figure is known as a convex polygon. So this is an example of a convex polygon. Similarly, you can have another figure. Let's say this is a pentagon with five sides. I am going to draw a diagonal 1, a diagonal 2, another diagonal here. Whatever diagonals I am drawing from one point to the other, I find that all the diagonals are lying within the figure. So this is also an example of a convex polygon. Now, if these are convex polygons, then what are concave polygons? Concave polygons will be figures where the diagonal will lie outside the figure. So if you are joining this diagonal here, this is inside, but if I am joining this vertex to this vertex, then what happens is that this diagonal lies outside the basic figure. So therefore, if I name this as ABCD, we find that one diagonal lies inside, but the other diagonal is outside. So when diagonals are lying outside, then such type of figures are called concave polygons. Now let us find out what is the way to find out the total sum of angles of any figure. For example, if we have a triangle, we know that the sum of angles A, B and C is 180 degrees. Therefore, if you have a quadrilateral, what will be the sum of angles? here A plus B plus C plus D is going to be 360. The reason being that I can divide this quadrilateral into two parts. So here we have one triangle and here we have the second triangle. So 180 here and 180 here. So 180 plus 180, 360. If I apply this process to again another figure, let's say a pentagon can now be divided into three triangles. So this is going to be 1, 2 and 3. So this is going to be 180 multiplied by 3. This is going to be 540 degrees. So this is one process by which we can find out the sum of angles of any polygon. But this becomes a very cumbersome process if the number of sides is large. Therefore, there is a formula by which we can directly find out the sum of angles, and that formula is n minus 2 multiplied by 180, where n stands for the number of sides. Now let us find out whether it is true for all these cases that we have discussed above. In the first case that we took, triangle, the triangle has got three sides, and if I am going to substitute the value of n as 3, so we get 3 minus 2, that's 1, and 1 multiplied by 180, we get 180 degrees. In the second case we saw a quadrilateral. The quadrilateral has got four sides, so this becomes 4 minus 2, that's 2 into 180, 2 into 180 becomes 360. In the next case we have a pentagon has five sides, so we get 5 minus 2, that's 3, and 3 into 180 is 540. Therefore, in the exam you could be given n number of sides, and therefore it is very easy to find out what will be the sum of angles of the figure. Let us say the example, if we want to find out the sum of angles of a nonagon. A nonagon, as we are aware, is a figure in which it has 9 sides. So using the formula n minus 2 into 180, we will get n value as 9, so 9 minus 2 multiplied by 180 degrees. So 180 into 7 will give us the sum of angles of this nonagon. So this is 7 into 0, 0, 8 7s are 56, so 6 and 5 carried over, 7 into 1 is 7, 7 plus 5, 12. So sum of angles of a nonagon will be 1260 degrees. So this process can be repeated for n number of figures, n number of sides. Provided we know the number of sides, we will be able to find out the sum of angles of that particular. Let us look at this quadrilateral. Three angles of the quadrilateral are given, 60, 80 and 120, and there are some unknown angles here represented by the alphabets A, B, X and Y. And the question says find the value of X plus Y plus A plus B. Here we will have to remember one property before solving this question, which is called the linear pair property or the linear pair axiom. What is the linear pair axiom? If you are having two angles which are lying along a straight line, the linear pair axiom says that the sum of those two angles will always give us 180 degrees. So here we can say that angle 1 plus angle 2 is 180 degrees. So in this question we will have to use this linear pair axiom and use this property to find out these unknown values. So here in the first case we find that this is a line, the angle here is 60 degrees. So A can be found out by subtracting 60 from 180, because A plus 60 should give us 180 by this linear pair axiom. So A becomes 180 minus 60, therefore the value of A is 120 degrees. Repeat the process here, we get the value of Y as 180 minus 80, that is going to be 100. The value of X similarly using linear pair axiom will be 180 minus 120, and 180 minus 120 we get 60 degrees. Now to find the fourth angle, that is B, there is no term inside the quadrilateral, and therefore this fourth angle has to be first found out. How do we find the fourth angle? Because this three angles are given and we know that sum of angles of a quadrilateral is 360. So what has to be done in this case is that we will have to add 120, the first angle, plus 80, the second angle, 60, which is the third angle, and this total is going to be 0 here, 6 plus 8, 14, and 2, 16. 1 carried over, so we get 260 degrees as the total of the three angles. Now, if the total of the three angles is 260, the third angle, which is unknown at the moment, can be found by subtracting this total from 360. So, 360 minus 260, we will get 100 degrees. Now, the fourth angle that was unknown initially has now been found out, and that angle is 100 degrees. And therefore, we can say that B will be 180 minus, and this is 100 here. So, using linear pair axiom now, it is easy to find out the value of B. So, 180 minus 100, we will get 80 degrees. So, we have the first angle, that is A, 120 degrees. The second angle Y as 100 degrees. The third angle X as 60 degrees. And the fourth angle B as 80 degrees. So, we have found out A, Y, X and B. Now, the question says find X plus Y plus A plus B. So, if you are going to add all this, so we get 120 and 100 as 220, 220 and 60 will give you 280, 280 and 80, the total will be 360 degrees. Now, here the total of these angles we have obtained as 360, and if you observe, all these are exterior angles. The exterior angles will always give you a total of 360 degrees. So, if you get any other answer besides 360, that means you will have to check on the calculation, because this is a very important property that if the exterior angles of a polygon are added, the result will always be 360 degrees.